Hi, today we are going to cover the concept of impulse. We apply impulse when we are applying force for a very short duration. Like, for example, there's a ball lying on the ground, and you come here, and for some fraction of seconds, right? In fraction of seconds, you kick it, right? So it goes away. So, what is happening here? You're applying some force for some time, let's say time t, or we can calculate change in time, right? F delta t. This will be called impulse, how much you are applying. So we denote it by the letter J. So you can call it a jimpulse if you want. So this is what the impulse is. But this is the cause you are doing. This is what you are doing some action on this ball, right? So now let's say example you have applied force of say 10 Newton and the time taken delta t is noted as 0.02 seconds. Always we talk about impulse when the duration is very, very less. In fraction of seconds, 1 or 2 seconds, not more than that generally. Now, I have to calculate impulse and that will be 10 into 0.02, 0.2. What with the units? Units will be Newton, right? Because it is force. And then I will discuss it, multiply it with time, Newton second. So this much impulse you have applied. So this is the first concept. We can calculate it, right? About like what is a force multiplied by delta t. And this much impulse or impulse we have calculated. Now, if this is a cause, what will happen? What will be the effect, right? So if this is a cause, what is the effect? Effect, you can see it later, right? If you kick it with some force for smaller duration, you can calculate this much impulse you have applied. And after that, due to that, the effect will be its velocity will change or its momentum will change. And that is what the change in momentum will be the effect. So it turns out that F delta t, how much you have given the impulse, is equal to change in momentum. So this is the relation between change in momentum and the impulse. And this equation helps us to calculate different aspects if something is missing here and find the variable which is not given to us, which will be clearer as we are moving towards the problems. So let's do the first question. Here, there is a puck of 0.160 kg is traveling at speed. The speed is given 5 meter per second and northwise. The direction is also given. A slap shot produces a collision that lasts 0.002 seconds and gives the puck a velocity of 40 meter per second south. So first of all, we will draw a diagram and how things are happening. So here is a puck, say, and its mass is given 0.160 kg and it was going 5 meter per second here, 5.0 meter per second north going upwards, and gives we slap shot is given which happens a collision with the hockey stick, right? And it moves downwards afterwards. So downwards I'm writing with a dotted so that you know it is happening afterwards, and I'm keeping this arrow big so that we understand that this is it should be 8 times actually this, so around just showing this value 40 meter per second. So this is what has happened after the stick has stuck to this puck, right? So this is what the question is saying. Now what they're asking is calculate the impulse imparted by the hockey stick. See, no force is given. How we can calculate? So the time of this collision of hockey stick with the puck, that time is given delta t is given 0.0020 second. See, always we talk about the impulse when the time duration is very, 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 very small. Okay, so now what we can do? We know that impulse is equal to change in momentum. We will use that equation to solve this question. So the impulse here is F dot delta t, and that will be change in momentum. change in momentum. Okay, so we will use this equation to solve this. So what we can get and calculate easily, see this change in momentum can be calculated. So what will be the change in momentum? Delta P will be final momentum minus initial momentum. And always remember, whenever we are talking about momentums, we will always take care of the signs because this is a vector quantity. That is one big catch here. Now, so the PF will be mass 0.160 into minus 40 because it is going downwards minus what is PI initial. So it was going up, we will take as positive. So 0.160 into 5. So we can say it will come as 0.160 into minus 45. And then we can calculate this. Let me have a calculator. And it'll come 0.160 multiplied by 45. Okay, 7.2. So 7.2 change in momentum is kilogram meter per second, the units. So that much change in momentum has happened. Okay. So this is what our first equation we were able to calculate. Now, what is even asked? See the part A, calculate the impulse imparted by the hockey stick. So we can easily calculate because see, we have calculated change in momentum. So that will be equal to the impulse. The product of that will be equal to this. So if we have calculated this, we have already calculated impulse. So this will be the answer of the first part. Now let's see the B part. B part asks what is the force? Determine the average force applied by the stick to the puck. Still, we can use this equation, but now we can put the time. See, here we don't need have to put time to calculate anything, but time is also given, and that is given so that we can calculate this force. So the force multiplied by 0.0020 will be equal to change in momentum, which is, sorry, I forgot the minus sign, minus 7.2 kilogram meter per second. And now, can I calculate force? Yes, I will just divide it and calculator again. 7.2 will be divided by 0.002 and that will be 3600. And don't forget the negative sign. What does that mean? So we have calculated average force is this much. Okay, average force is this much, and but remember the force which you have applied is in the negative, means it is downwards. So the direction of force is this. So this is what this negative sign signifies. Now we are moving towards the next topic, which is collisions. Now, what kind of collisions we can have? So generally we segregate in two categories. One is elastic collision, and the inelastic collision. And you will also hear the terms like perfectly elastic collision and perfectly inelastic collision, but that means around same. So now here elastic collision, what will happen, and inelastic collision, what will happen. One thing will be common, that in both the cases momentum will be conserved. So whatever the initial momentum of the system, it will remain after the collision too. So that is the commonality between these two. Whatever it is elastic or inelastic, the momentum must be conserved. So what is the difference? There will be something which is not conserved, and that is kinetic energy. So in elastic collisions, the kinetic energy of the system is conserved, like elastic. It comes back, it gives it back the same kinetic energy. And in inelastic collision, you guessed it right, kinetic energy is not conserved. Also, please, there is one term which comes like perfectly inelastic collision. What does that mean? In that, if two things are colliding, okay, it is going like that, it is going coming like that, okay, and they collide, and afterwards what will happen? They will move together. They will stick to each other and move as one object. So this is what the condition is for perfectly inelastic collision. And these are the conditions for momentum and kinetic energy, how they are for elastic collision and inelastic collision. I remember it like that, like if you say take some elastic thing, okay, so if you stretch it, and I can see kinetic energy here. So if you stretch it and remove it, the Ke will come back. So kinetic energy is conserved in elastic collision, and in inelastic collision, it is not conserved. So let us understand collisions by simple example, numericals. That's the best way to understand these concepts. So suppose you have two balls with different masses involved. In a perfectly elastic condition, you got this point, perfectly elastic collision means the kinetic energy will be conserved. Ball 1 with mass of 0.26 kg. So I will try to draw a diagram like that. So it is, let's say M1, that is 0.26 kg, traveling at a velocity v1 1.3 meter per second towards the right. So it is moving like this with the 1.3 meter per second towards the right. Collides head on with a stationary ball 2. So this is the ball 2, say. It is stationary, it does not have any initial velocity. It is at rest, which has a mass of m2. So this is m2, which is given 0.5 kg, 0.15 kg. It is lighter than this. Now, what they have asked is determine the final velocity of both balls after the collision. What will happen? What will be their velocities after the collision? So now what we need to do, we know two things. First things, whatever the collision is, the momentum will be conserved. Second thing, the kinetic energy will be conserved. And using these two principles, we can easily get equations where we can solve for velocities. Let's try first what is the conservation of momentum says. So we have to see the momentum conservation as a system. So let's see how we can represent it. And please note it down, the difficult part here in these kind of question is to write down the subscripts, which you will understand as we write. So what first I want to understand, like conservation of momentum. I want to apply conservation of momentum. So whatever the momentum the system has initially, that should be the final. It will be same. So what will the initial momentum of this? So I can apply P initial. This is we are talking about the system, not a one product. So P initial will be M1 and V, you can say initial, right? Of what? 1. Remember that is the subscript problem, right? So don't get confused in that, write them carefully. So what I'm saying, initial velocity of M1. So that is what M1 VI1, right? And then it will be plus momentum of this M2 and VI of 2. So these subscript, please focus on that so that when the problem becomes complex, you'll not be confused. So writing these subscript carefully is very important. So this was the initial one, and what will be the final one? So final momentum will be M1 V final 1. See, I wrote by final 1 plus m2 v final velocity of 2, the second mass. And they have to be equal, right? They should be equal. So I can remove this and put equal to sign. So this is what it says. The conservation of momentum says this should happen. So now let's put the values here. Okay, so my initial momentum will be m1 is 0.26. Okay, VI1, do I know the initial velocity? Yes, 1.3. Remember, whenever we are talking about momentum, we always have to take care of the signs. So velocity will make these signs positive or negative, whether momentum is positive or negative. We have to choose. And in the case of this, we can choose right side as positive. It's our choice, but I'm taking right side as positive. So I will consider VI1 because it is on the right side as positive value. So I will just keep 1.3. Now, what about M2? M2 is 0.15. See here, M2 is 0.15 and multiplied by initial velocity of this, and that is 0. It was at rest before collision. So initial momentum is what happened before collision, and final momentum will be what will happen after collision. Okay, so we have reached here. Now let me calculate this. So it will be 0.26, and these things, both of them, we don't know. We don't know the final velocity of first mass, and also we don't know what is the final velocity of the second mass. So this is what we have come to. Okay, so now let me simplify this. So this is 0, so it will cut out. I will calculate this with my calculator. It is 0.26 multiplied by 1.1.3, and that will be 0.338. So it will be 0.338. That will be equal to 0.26 VF1 plus 0.15 VF2. But we cannot get answers with one equation. Why? Because we have one equation and we have two variables. We don't know the final velocity of the first mass, and we also don't know the final velocity of the second mass. So what to do? We need another equation. And in the question, they have told that it is perfectly elastic collision. So that gives us a hint how we can make the second equation. So let us use this. Let's have a perfect elastic collisions. Their kinetic energies should be same. So what we can say, whatever the system's kinetic energy initial, that has to be equal to kinetic energy final. So that is what. So let's calculate the initial kinetic energy. So KEI, I can say that will be half. What is the mass? M1, 0.26 into V square. Now, in case of kinetic energy, we don't have to take care of the signs because it's a scalar product. Even if we'll put square, because half mv square is the formula for kinetic energy. So this square takes care of the negative sign. If even if I put a negative sign, it will square it, so it will not matter. So we just have to take the absolute values, and that's it. So this is squared. And what was the kinetic energy of this? Yeah, I don't have to write it, but I just wanted to show you that its kinetic energy, the velocity was 0. It was at rest, right? So this will cut out, and we will have only this. So let me calculate this before calculating the final kinetic energy. So it will be half multiplied by 0.26 multiplied by 1.3 squared. So that will be 0.2197. So that will be 0.2197. It's the energy, so the units will be joules. So this is the initial kinetic energy. Now let's go further and calculate the final kinetic energy. So now we can calculate the kinetic energy final, and that will be half. What is the mass? Mass is 0.26 multiplied by V final of M1 squared, plus it will be half 0.15 multiplied by velocity of final velocity of the second mass squared. And this is our second equation. Now we have got two equations which have two variables, and that's how we solve these kind of problems. Yeah. So let me write a kinetic energy equation. So let's apply this now. So let us apply this now. So 0.2197 must be equal to half into 0.26 into VF1 squared plus half into 0.15 into VF2 squared. So this is our second equation. This is our second equation where we have again two variables. We have first equation by the conservation of momentum. Now we can play around. That is, now the problem has become to solve two equations having two variables. Okay, so we have two equations here, but now remember this step. I will do again this step from now onwards, and but in that case I will use a shortcut. But as of now, just remember that let's do with solving these kind of problems if we want to do straight away with the math. Here are two variables, two equations. One is squared, right? So we'll end up getting a quadratic equations. We can't, escape that if we do conventionally. So that is what I'm going to do. So remember that. So now first I will take take this VF2 and get that in terms of VF1. So that's what the first thing is do. So I'll be putting it that side. So I will put 0.338 minus 0.26 into VF1. That will be equal to 0.15 VF2. Let me take 0.515 to other side. VF2. So it will divide like that 0.15, and I am going to solve this. So that will be 0.338. 0.338 divided by zero point 0.15, that is 2.253. So it will be 2.253 minus, I will divide this now, 0.26. 0.26 divided by 0.15, that comes out to be 1.733. 1.733 VF1, that is equal to VF2. So that is, I got VF2 in terms of VF1. Now we can put this value of VF2 here, right, in the second equation which we got from the conservation of kinetic energy, and that way we will get a single equation which has only one variable, which is final velocity of mass object 1. So that is what we are going to do. So let's do that. So I'm writing second equation again. 2.197 will be equal to, let me clarify this also, half divided by 0.26 will be 0.13, and that will be multiplied by VF1 squared. VF1 squared. Then 0.15 divided by 2 we need to do. So I'm simplifying it. So it will be 0.075, 0.075. And here the value of this goes, this one. So it will be 2.253 minus 1.733. Yeah, I understand. You'll be thinking like it's so messy. And I understand that even one decimal goes wrong. So I'll end up getting the wrong answer. So I understand the gravity and how this problem becomes difficult. Okay, so now we have this one. So now we have to clarify this part, because this is squared. So this will be 0.075 a square. So this is a minus b whole squared. So that is what the a square will be, 2.253 squared. That will be 5.076, okay, plus b square. So this will be 1.733 squared. That will be 3.00, 3.0032. 3 I'm picking VF1 squared, okay, and then minus 2AB. So 2 multiplied by 2.253 multiplied by 1.733. Okay, 7.8 minus 7.8, 1 we can say VF1. So this is what we got by simplifying this. Now I have to multiply this guy to this. Okay, so let's be patient. I'll be going to do that. So that will be 0.075, 0.075 multiplied by 5.076. That gives me 0.3807, plus I will multiply this now. This will be 0.075 multiplied by 3.003. That will give me 0.225. 0.225 VF1 squared minus, again need to multiply 0.075 into 7.81. So that will be 0.585 VF1. So now we got this. So a little bit relief. The difficult part is done. Okay, so now we just need to rearrange. Let's make a quadratic equation, keep this guy, take to other side, so it will be subtracted from this. So 0.3807, I will subtract 0.2197 into it, and I will get 0.161. So I can say 0.161, and then I can collect this because these are both squared. So 0.13 plus 0.225. So that gives me plus 0.355 VF1 squared. And then only this is remaining now. We have taken care of everything. So this will be minus 0.585 VF1. That will be equal to 0. So just rearrange it in a general style of writing quadratic equation. So first x square vf1 squared minus 0.585 vf1 plus 0.161, and that has to be equal to 0. Now I have to solve this quadratic equation. Vf1 I need to calculate. Now if we solve this quadratic equation which we got, we will get two answers. One will be, one I'm getting vf1 should be equal to 1.3, and other solution which I'm getting is 0.35. 0.35. So which one I should reject? See, the first one can't be possible. Why? See, the velocity was of 1.3 meter per second, and I'm talking about the speed final velocity of this mass again as 1.3, like it just passes through. It does not interfere with it, but it is having collision, so that can't be true. So my answer will be this option, or this solution of the quadratic equation I will take 0.35. Now using this formula which we have already calculated, we can calculate vf2. We just need to put the found out value of vf1 here. So let's do that. So it will be 2.253 minus 1.733 into 0.35. That will be vf2. Let me use my calculator. So 2.25 minus 1.733 into 0.35, that will be 1.64. So, and yeah, 1.64, 1.643 it is. I'm taking two decimal places, say, and meter per second. So that will be my final velocity. That's what they have asked. Now, I understand what was the problem here. When the problem got started happening messy, when we had to solve this quadratic equation. What if I tell you that there was a shorter solution for that? This was a shortcut. And let's go back to that point. So now let's do this problem in a very simple manner, in a shortcut manner. So now what's the problem here is we are not going to use kinetic energy conservation principle. So we will use one fact for the perfectly elastic collision, that the velocities before and after, if you do the addition, that will be same. So for example, this guy's initial velocity v initial of 1, if you add that up with the velocity which it finally will get, f1, velocity, final velocity of 1, that will be equal to velocity initial of 2 plus velocity final velocity of 2. So that fact, this fact will give us another linear equation which we can compare and solve this question very easily. No need of quadratic equation. So let's put some values here. So what was the initial velocity? We know it was 1.3. It's a positive. I will keep 1.3 plus final velocity. We don't know of 1. What will happen? Initial velocity we know this is 0, and this is vf2. We don't know, right? So this will give us a very simple relation that vf2, the final velocity of mass object 2, will be just addition 1.3 plus vf1. Now we can use this equation into this. So let's use that. So we, instead of VF2, I can put this. So let me solve further. So that will be 0.338 will be equal to 0.26 V final velocity of 1 plus 0.15, and instead of VF2 I can put this 1.3 plus VF1. Now let me go further. Yeah, so now I can say I will solve this part. So it will be plus 0.15. Let me have my calculator. 0.15 multiplied by 1.3. That will be 0.195 plus it will get multiplied inside 0.15 VF1. And here it is 0.26 VF1, and here it is 0.338. So let me solve this. I will take this to another side and subtract it from 0.338. So 0.338 minus 0.195 will be 0.143. I will add them up. 0.26 plus 0.15, 0.26 plus 0.15, that will be 0.41, 0.41 multiplied by VF1. So I need to calculate VF1. So I just need to divide 0.143 divided by 0.41, and that will give me 0.35. So VF1 I'm getting 0.35 as we were getting there, but with very small steps, simple steps, solving only the linear equations. What about VF2? VF2 we can calculate from here. I just need to add 3.5 and I have to add 1.3 and I will get 1.648, or I am getting around 1.65. We are getting the same answer but with a simpler solution.